Finally, after 6 years of waiting, we're going to vote. However, how are we going to vote if there's no election ballots? I wonder how people get these election ballots in the safest and fastest route. Well, here it goes. Please welcome the Secretary of the Regional Director of Region 3, Director Surmieda.
Good day, fellow citizens. I would like to announce that the election ballots will be delivered safely. I hired a team responsible for the matter. I would like to call this project as the Election Ballot Delivery Route Optimization.
You'll never make it. You're nothing but a second rate. Trying hard. Copycat.
Welcome to our team. Wait a minute. I see your faces asking, how these people do their jobs? Simple. Through mathematics, or specifically, graph theory. Graph theory is a branch of mathematics focused on the network of points connected by lines. It takes the lead in representing the relationship and connectivity of the problem. Then, what is a graph?
According to Gupta, graphs are discrete structures consisting of vertices and edges that connect these vertices. It is also a pairwise relation between objects. In a connected graph, at least one path exists between every pair of vertices. If the edge in each graph G is assigned in a real number, called the weight of the edge, then G is a weighted graph. Now in this project, we're going to use the concepts mentioned before to its application called the vehicle road problem.
The concept of the vehicle road problem originated from the idea of Danzig and Ramsey, as what they called it back then, the truck dispatching problem. It is meant as a variation of the traveling salesman problem that can be used to optimize multiple routes for multiple vehicles. To solve VRP, the weight of each edge will be presented in tabular form to show a simplified version of the given graph. By referring to the table, multiple routes can be derived, and choosing the route that has the least weight will be the feasible solution for the given problem. A reminder that less vehicles used will cause more efficiency compared to using more.
This is the most exciting part. We are now going to apply these concepts for real.
We are asked to create a delivery route for the election ballots for Region 3, where San Fernando, Pampanga is considered as the central hub. Comelec reminds us to use as few vehicles as possible to not attract any unwanted attention. In this problem, each capital of the city of each province will serve as the vertex, while San Fernando, Pampanga will serve as the starting point. Naming the vertices with the order of 0 to 6 will make the graph easily understood. San Fernando will be the starting point, therefore it will be vertex 0. Iba Zambales will be vertex 1, Tarlac City will be vertex 2, while Palayan Nueva Ecija will be vertex 3, Balanga Bataan will be vertex 4, while Malolos Bulacan will be vertex 5. Lastly, Baler Aurora will be vertex 6. The edges connect each city in accordance with how each city will be traversed in real life based on hours. Each edge will have a designated weight that shows the travel time of the two cities connected by an edge. A weighted graph will be used to present the optimized route to be taken.
The figure shows the graph derived from the map of Region 3, complete with the vertices connected by the edges, and the edges having their designated weight in accordance with the travel time between the connected cities. Putting the information from the graph, we can create a table. It shows the table of values that are from the graph of Figure 1. Tabulating the information is necessary to assess the possible routes. 0 will serve as the default while the numbers will be the remaining cities.
Now, for a change, let's try when there's restriction. By looking to the figure, it shows the one restriction in edge 1 and 2. As the path between them is covered with impassable mountains, this change will also reflect the values present in Table 1. Table 2 will then show this change. By consulting both Figure 2 and Table 2, we can generate routes that can satisfy the BRP condition through observation and analysis. With the use of deduction, we can determine the most efficient route, which is 0 to 1 to 4 to 0, which is 7.01, and 0 to 2 to 3 to 6 to 3, then 5 is equals to 10.86. 7.01 plus 10.86 is equivalent to 17.88.
Now, for the optimized route of Vehicle 1, from the starting point in San Fernando, vertex 0, we can go to Iba Zambales, vertex 1, for 3 hours and 20 minutes. Then, straight to Balanga Bataan, vertex 4, for 2 hours and 58 minutes. Then go back to San Fernando for 1 hour and 23 minutes, for a total of 7 hours and 1 minute.
Using the second vehicle, we can traverse from San Fernando with vertex 0 to Tarlac City or vertex 2 for an hour and 17 minutes. Then go to Palayan Nueva Ecija or vertex 3 for 1 hour and 45 minutes. Next is to Baler Aurora, vertex 6 for 2 hours and 39 minutes. Then we have a loop back to Palayan Nueva Ecija with vertex 3 for another 2 hours and 39 minutes. Went to Malolos, Bulacan with vertex 5 for 2 hours and 46 minutes as our last drop city. Finally, the second vehicle can go back to San Fernando of vertex 0 for an hour.
Vehicle 1 will traverse Route 1, while Vehicle 2 will journey on Route 2. The weight of the graph will be 17.88 hours, but the actual time needed to deliver the election ballots is around 10.86 hours.
Now, the task that is assigned with Director Sir Mieda is finally finished, and we'll just wait approval from Comelec. We've done our job! I hope you learn modeling and solving vehicle routing problems in the real world. Goodbye!